Professor Mr. K. Balraj is working as a polymer consultant and teaching fellow in the area of polymer science and engineering at CEG Anna University, Chennai. He has completed AMIE in electrical engineering at the Institution of Engineers, India, Calcutta, and MTech Polymer Science and Engineering at CEG Anna University. He is also pursuing his doctoral research work in polymer technology. His area of specialization includes polymer rheology, polymer processing, characterization and testing of polymers, polymer blends and composites, and insulation technology. He has in-depth experience on plastic properties, testing methods, and the relevant standards. He has more than 15 years of teaching experience in polymer science and engineering, including instrumentation in polymer industries, engineering plastics, conducting polymers, and rubber technology at CEG Anna University. He has guided more than 30 MTech students in their research projects. He has presented more than 20 research papers in the national and international conferences in the area of polymer science. He has published 10 research papers in the peer-reviewed journals.
Welcome to UGC lecture series in polymer science. In polymer science, the course what we have been discussing so far is about polymer processing and mold design. In the last class, we have discussed about extrusion molding. In today's class, we will discuss about injection molding, the injection molding process, the types of injection molding machine, and then the types of molds used in injection molding. First, what is meant by injection molding? Injection molding is the most common plastic molding method where molten resin is injected at high pressure into a mold. So, unlike a extrusion molding where the melt is allowed to flow out of the die, here it is injected high pressure into a closed mold, and then it is allowed to cool until it becomes solid, and finally the product is ejected from the mold. So, injection molding constitutes almost 32% of the commercially polymer processing methods that are used to prepare plastic products. Injection molding, the types of materials that are used in injection molding includes metals, which is normally what we call it as die casting, glasses, elastomers, that is rubbery materials, but then the most common material the injection molding process is meant for is nothing but the thermoplastic as well as thermosetting polymers. In the injection molding process, the molten plastic material is injected into a mold where it is allowed to cool into a plastic product. The process starts with placing the plastic raw material in a hopper, that is the starting point where the pellets are loaded, which will be fed into a heated injection barrel. The melted plastic is then injected at high pressure into closed mold where it will cool down, and eventually it is ejected as a molded product. The three main parts of an injection molding machine are the injection unit, the mold, and then the clamping unit. So, this typical scheme showing the three main components of the injection molding machine. Starting from the injection unit, it has a single screw extruder, what we have seen in the last episode in the extrusion molding machine. We have seen that the single screw extruder is not, this is the single screw extruder, it is not only meant for extrusion molding, the same could be used in injection molding or injection blow molding, or sometimes it is also used to compound the plastics. So, it consists of a so therefore, the injection unit consists of a single screw extruder supported by a hydraulic system. So, this hydraulic motor provides the necessary torque to rotate the screw. As a result, the polymeric pellets are melted and mixed thoroughly, and then at the end of this single screw extruder is what we have a nozzle. The second component is the mold. In the mold, you have two parts, one is male mold, another one is the female mold. So, one mold is a stationary mold, mostly this female mold, this is the stationary mold which forms the end of the injection unit, and then the movable part of the mold is connected with the clamping unit. So, the clamping unit can close this mold, and then it can also open this mold. So, this is a typical scheme of a injection molding machine. We will see one by one. So, the injection unit is used to melt and soften the solid resin and inject a set amount of molten resin into the mold. So, that is what is the exact volume of the melt that would occupy the mold is has to be calculated. Accordingly, the amount is set. The detailed parts of the injection unit. The first, the injection cylinder, which includes the screw, the single screw extruder, the nozzle at the end of the screw, the hopper, that is where the raw materials are fed in the form of either pellet or powder, and then single screw extruder is surrounded by heaters that will set the necessary temperature for melting the polymeric resin. And then the injection screw, the purpose of the screw is not only to transport the resin from the hopper end to the mold end, but also to mix thoroughly, because additives are normally added, plasticizes and injects the material into the mold. And then the hopper, you have different types of hopper. Mostly we go for a gravity hopper, in which the pellets are added into the barrel simply by means of gravity. So, it is where the material is being stored or placed prior to the plastication. So, the plastication is nothing but the conversion of the either the pellet like plastic or the powder like plastic into a liquid resin. That is what we mean by plastication. Hopper is also designed to avoid material bridging in the feed throat and to let gravity feed the material. Next part of an injection unit is the heaters or heating elements. These elements surround the barrel. It heats up the injection cylinder so that the material will be melted. And the next important component on the most significant design with respect to the injection mold machine is the mold. When the two mold plates are brought together, that is, we have seen earlier in the diagram, there are two parts of the mold, one is fixed and the another one is movable. When these two are brought together, a space is created within the mold, which is what we call it as mold cavity. The molten resin is going to be injected into this space and it is allowed to cool until it becomes solid. The liquid resin, once it reaches the solid surface of the mold, it solidifies. Then the mold is opened and the product is ejected. And then the third component is the clamping unit. The clamping unit is used to hold the mold tightly during the injection at high pressure. The clamping unit accommodates the movable part of the mold and it fulfills the following function, that is, the closing and opening of the mold depends on the operation of the clamping unit, whether it moves forward or whether it moves reverse, and building up of the necessary clamping force, because high pressure has to be maintained inside the mold. So, therefore, sufficient clamping force has to be generated, which is done by the clamping unit, and locking the clamping unit, and then retention of the locking force. Once the product gets solidified, the clamping unit has to retract back, and then finally the ejection of the molded part, that is, ejector pins are available in the clamping unit, which will eject the molded product once it is solidified. Now, the melting of either plastic pellets or powder in a barrel, that is the barrel part of the single screw extruder, is done by external heating, either in the form of hot gases or steam, or sometimes electrical resistance are embedded, and that is how the necessary heat is generated, and also due to the frictional effect between the screw and the barrel. The melt is forced into a split die chamber either by a hydraulic plunger or by the rotating screw system of an extruder. Accordingly, there are two types of injection molding machine. One is plunger type injection molding machine, which is the oldest one, and then the recent one is the reciprocating rotating screw type injection molding machine. The second one is similar to the extrusion molding machine, only thing is it has a clamping unit to close the mold. We will see one by one. So, this is a typical scheme of an injection molding, plunger type injection molding. The plunger type injection molding, it has a ram which can move forward and backward. Once the injection chamber is sufficiently filled with the required quantity of resin, now the piston ram moves forward and then pushes this resin through this nozzle, and then it reaches the mold, and that is how the injection molding takes place. Whereas reciprocating means moving forward and backward, and a rotating screw type injection molding machine, it has a now it has two different plates which has two parts of the mold, and the single screw extruder is attached to the fixed end of the mold, and then the clamping unit has the movable end of the mold. So, here unlike the plunger type, the screw only rotates, it only rotates, and then it does the necessary plastification process, and then once the resin is completely melt, the screw moves forward and pushes the resin into this mold, and then the injection molding takes place. So, this is a typically available commercially available injection molding machine. These machines are normally rated based on its capacity. For example, this machine is of capacity 250 ton. So, the tonnage is the force applied to keep the dies closed during the injection of the molten plastic into the mold cavity. So, that is the tonnage of the machine will directly determine the clamping force that is required for molding. So, this is again a simplified view of injection molding with a reciprocating and a rotating screw type. So, here you can see the again a single screw. The screw depth is going to vary from the hopper end to the molding, and we will see why. The reciprocating screw compresses and melts the plastic material, that is the main role of a single screw extruder. It also moves the material towards the die. The reciprocating screw is divided into three zones: the feed zone, the transition zone, and the mid-ring zone, similar to the extrusion process what we have seen in the last episode. Now, the outside diameter of the screw remains constant in all the zones, but the depth of the screw flight will decrease from the feeding zone to the mid-ring zone, because at the feeding zone the plastic pellets, the more number of plastic pellets has to be added, and it has to be compactized. So, therefore, more depth is required at the feed end, whereas in the transition and mid-ring zone the pellets are converted into liquid resin, or it becomes a melt. So, therefore, this flight depth should decrease as we move from the feed zone to the mold zone. The flights of the screw compress the material against the inside of the barrel. So, that is how this motion actually creates a heat which is due to the viscous effect, or this is called as shear. Although there are heater bands on the surface of the barrel, this shear heat is the primary heat that actually melts the plastic. Therefore, the main function of the heater band is to maintain the temperature of the molten material. Now, at the end of the screw you have the nozzle. The nozzle forms a sealed connection between the barrel as well as a sprue bushing of the mold. The temperature of the nozzle is usually set near the plastic's melt temperature. The mold sprue bushing has a concave radius. The nozzle fits into this radius with the aid of a locating ring. Now, the molten plastic is forced into the mold cavity. This has to be injected at a very high pressure. The normal injection molding pressure for the most of the thermoplastics or thermosetting resins include will range from 70 megapascal to 200 megapascal. Based on this pressure, the tonnage of the injection molding machines are rated. Now, typical injection molded products are cups, fridge doors, auto bumpers, housings, tool handles. Almost any type of plastic products could be injection molded. Even a plastic chair, or the cabinet for the mobile, or for a torchlight, or for the holder, electronic holders. So, there is a quite almost any type of plastic product could be injection molded. The only thing is the cost, the preparation, the cost associated in preparing a mold for a given type of product. Now, we will look into the different stages of the injection molding machine. Typically, it involves 4 stages. So, in the first stage, the clamping unit moves in this direction as shown here. It moves with a given velocity because the movable pattern is associated with the clamping unit. Now, the first step is the closing of the mold. Once the mold is closed, a mold cavity is created. In the second stage, now the single screw rotates, the reciprocating screw rotates in this direction, again with a given speed as well as with the force which is the clamping force, and then you have a non-return wall at the end of the screw, which will ensure that once the resin flows through this nozzle, it is not allowed to flow back into the barrel. So, the second stage is the movement of the screw. As a result, the resin occupies the cavity inside the mold. The polymer melt occupies the cavity inside the mold. In the third stage, the sufficient time is given for the polymeric melt to solidify. In the meantime, fresh polymer melt is allowed to fill up the barrel, and then this screw is ready for further operation. That is, normally capacity or the production rate of a injection molding machine is very high. So, therefore, as soon as this product solidified, it is ejected out. The next product, polymeric melt required, what we call it as the short capacity. The short capacity of the injection molding machine has to be pumped inside this mold. So, in the third stage, your the reciprocating screw rotates back in this direction, it rotates in the reverse direction, and as a result the more fresh polymeric melt will go and occupy near the nozzle region. So, in the fourth stage, the ejector pins will eject the molded product as shown here. The product is ejected out from the mold. So, these are the typical stages in the injection molding process. The more detailed explanation, the granulated or powdered thermoplastic fed from a hopper into the injection molding machine. That is the first step. In the second step, the injection molding machine consists of a hollow steel barrel inside which the single screw is housed. Now, the screw carries the plastic along the barrel to the mold. The heaters surround the barrel will also help in melting the plastic as it travels along the barrel. In the third stage, the screw is forced back as the melted plastic collects at the end of the barrel. Once enough plastic has collected, a hydraulic ram pushes the screw forward, injecting the plastic through a sprue. We will see what is a sprue into a mold cavity. Now, the mold is warmed before injecting, and the plastic is injected quickly to prevent it from hardening before the mold is full. So, therefore, the mold has to be maintained at a desired temperature, and also the injection time has to be set in such a way the resin should not melt inside the sprue. That is, a continuous flow of polymeric melt until it fills the mold has to take place. In the fourth stage, pressure is maintained for a short time, which is called as the dwell time, to prevent the material creeping back during setting. Now, this will also prevent shrinkage and hollows, therefore, gives a better quality product. Normally, injection molding machine, the shrinkage is the main problem. Once the product solidifies, normally there will be 0.05% shrinkage with respect to the overall dimensions of the product takes place. So, accordingly, the mold has to be designed for a higher dimension, that is, a tolerance limit of 0.05% has to be taken into account once you design the mold. Molding is left to cool before removing the product from the mold. Now, the molding takes on the shape of the mold. So, the molding here refers to the product. Next, the important component of the injection molding machine, as we have seen earlier, is the mold. The mold is important almost in any molding method, but then it is more important especially in injection molding. Now, the quality of the mold design has a powerful effect on many of the factors that will include the dimensional accuracy, the number one, the attractiveness of the product surface, uneven or even finish of the product, and then the speed of the molding process. So, that means the what we call it as the cycle time. The cycle time in the injection molding starts from right from the injection of the resin into the mold, followed by the solidification of the liquid resin into solid inside the mold, and then ejection of the product from the mold. This all comes in the cycle time. A typical time cycle time is 1 minute to 2 minutes for most of the commonly day to day used plastic products. So, therefore, the speed of the molding process will again depend on the design of the mold. So, this is the three dimensional form of a typical two plate mold, and this is the plate that is used to support the This is the core plate that is used to support this core. These are the core inserts that will insert into the four corners of this female mold, and then this is the actual core, and this is the cavity, and then this is the cavity plate supports the cavity. And for this mold, this is the type of molded product that we could make. Now, the entire mold is kept at a constant temperature just below Tg, that is the glass transition temperature or the melt temperature of the polymer that is used. Now, the melt exits the nozzle of the injection unit and flows through the sprue, runner and gate. So, this is a typical sequence for the polymeric melt. Once it exits the nozzle, it follows this pattern, that is, it first flows through the sprue, followed by runner and followed by gate, and finally it enters the mold cavity. So, this is a two dimensional view. This is the nozzle, which is the end of a typical single screw extruder, and now this conical shaped portion is what we call it as sprue. So, this is the entrance for the polymeric melt to flow through the cavity, and these are the runners that will carry the resin to the mold cavity and finally the mold cavity. And these are the ejector pins. Once the polymer gets solidified, this will move in the forward direction, and then the product could be removed. And also cooling channels are provided or embedded inside both the molds to maintain appropriate temperature. Now, each of these structural elements of the mold, that is the sprue, runner as well as gate, performs well defined functions, and this will have a direct effect on the quality of the injection molding operation. Now, the sprue forms the overall entrance into the mold. Now, the requirement of the sprue is that it should not generate any large resistance to flow. That means there should be minimum resistance for the flow to pass from the nozzle and then through the sprue. At the same time, the melt in it should quickly solidify upon completion of injection. Once the mold is full, it has to immediately solidify, because if it is not going to solidify, more amount of resin, liquid resin will flow through the sprue. So, that will result in more wastages of material and should be extracted from it without difficulty. The sprue should also form a streamlined transition between the nozzle and the runner system. All these functions are attainable by a short diverging conical shape. Now, next the runner. The function of the runner system is to bring the hot melt to the cavity. So, the runner forms the in between from the sprue to the mold cavity, and this should be done with the minimum of material wastage as well as minimum of pressure drop. As we have seen earlier, the liquid resin is injected into the mold at a very high pressure, and there should be minimum pressure drop that should be experienced by the resin. If there is uneven pressure drop, that will create a hollowness inside the plastic product. Therefore, the runner conduit length, the length of the runner must be kept to a minimum. It should not be too high or it should not be too low, and also as well as the cross section. The cross section has to be optimized for various factors, including low pressure drop. The pressure drop should be less, there should be less material waste, and there should be relatively slow cooling. It should not cool fast or it should not cool slow, and avoiding premature solidification. Solidification should not take place in the runner. If it is if premature solidification takes place inside the runner, then that will result in improper filling of the mold, or the mold will be filled partially. So, therefore, premature solidification is an important factor that has to be taken into account. That is what will result in short shots. Short shots are nothing but the not fully filled mold, that is, the product dimension would be decreased with respect to short shot. Generally, the runner is about 1.5 times the thickness of the molded part. That is the typical dimension for runner, and it is usually of circular cross section, but then other geometries are also in use that will minimize the heat loss, as well as that will also facilitate easy machining. When you prepare a mold, the mold preparation would also be easy. And then with respect to runner, savings in the polymeric material, and then the faster cycle time, can be achieved by hot runner system, where the polymer in the runners is prevented from solidifying through heating the units built around them in the mold plate, housing them in hot runner mold. So, the hot runner mold is another variation of mold, wherein you have heating elements that are heating units that are embedded on the surface of the mold, that will maintain a constant temperature, preventing the resin from solidifying. So, these are the types of mold used in injection molding machine. There are basically two types, 2 plate mold and 3 plate mold, and the hot runner mold is the variation of these 2 plate and 3 plate mold. So, this is a typical 2 plate mold, where you have one fixed plate and another mold plate, and this is a typical runner and a sprue. So, this is the shape of the product. This is shown in the form of ejected. So, in a 3 plate mold, you have a extra plate called stripper plate. By means of this, you can increase the output range. Other than that, 2 plate and 3 plate molds are same, except for a stripper plate. In a hot runner system, you have a hot heating units attached with one of the fixed plate. So, this will ensure that the mold is maintained at the constant temperature. Now, next the gate. The gate controls the flow of the polymer melt into the mold. Its size, shape and position are affected by a number of considerations. Generally, the gate length is about half the thickness of the section where the gate is attached. Usually, the heavy sections are considered for this. Now, these are the important functions of the gate. It has to allow rapid freezing of the polymer, that is, it should isolate the cavity and permits withdrawal of the screw, and a narrow and thin solid section be sheared off easily after demolding. Once the product is ejected out, these sections has to be unwanted portion has to be sheared off. Increase shear rates as melt flows through, that is, lower viscosity to ease rapid and complete filling of complex shapes. When the mold is of a more complicated and intricate design, and if the viscosity is high, then there will be a difficulty in filling up of the mold by the liquid by the polymeric resin. Therefore, in such cases higher shear rates are required as the melt flows through the gate. So, this is again another important function of the gate. To summarize, in today's class, what we have discussed is we have discussed extensively about injection molding, what is meant by the injection molding process, and the main components of injection molding machine. And there are basically two types of injection molding machine. One is plunger type, another one is reciprocating type, and the reciprocating and rotating screw type is the most common. And then the types of injection mold, 2 plate mold and the 3 plate mold, the difference between these two. With that, once the viewers go through this episode, these are the questions they should try to answer. What is injection molding? List and draw the 3 main parts of an injection molding machine. Describe the different stages in injection molding process. Distinguish between 2 plate and 3 plate mold, and state the functions of the gate. Thank you.